Hello everyone, welcome to another lecture series in our vibration subject for the aerospace engineering. In this video, we will see the topic in vibration isolation is one of the most important concept in the mechanical and aerospace engineering. Every machine produces vibration. Some vibration are useful while some are harmful because they reduce accuracy, create noise, causes fatigue failure, and shorten the life of the engineering components. This image sitting inside the aircraft during takeoff, although the engines generate tremendously vibration, passenger experience only minimum vibration. This is possible because of efficient vibration isolator system. In today's lecture, we'll learn how this vibration isolation is different and its types of vibration isolation systems and important design parameters and application in aerospace. This we'll see in better way by using a design thinking approach. Let's begin. Before we talk about the vibration isolation, let us understanding the objective of today's section. To understand this, defining the vibration isolation problems in engineering application. Second, I define the two major types in the vibration system: passive and active vibration isolators. Third, understanding the key design parameter including natural frequency, damping, and stiffness. Fourth, analyze the real aerospace application where vibration isolation improves safety, reliability, and passenger comfort. Finally, learn how the design thinking process can apply to solve this practical engineering knowledge of the vibrating system. So, to understand what vibration isolation actually means, vibration isolation is the process of preventing vibration from beginning tremendous transmitted from a vibration source of to the another object. Consider the aircraft engine. The engine continuously generates vibration during the operation. If these vibrations are generally hit directly transmitted to the aircraft structure, they can lead to structural failure, equipment malfunction, passenger discomfortable, and increases maintenance cost. To prevent this, engineers place vibration isolation between the vibration source and the structure. Three important concepts determine the effective of an isolator system. First is natural frequency. Every mechanical system has its own natural frequency. If extended vibration or external vibration matches this frequency, resonance occurs, which produces a large amplification, makes the large vibration. Second, damping. Damping dissipates vibration energy. Higher damping reduces oscillation of the system amplitude, especially near to the resonance. Third one is stiffness. Stiffness depends on the spring constant. Higher stiffness increases the natural frequency, will lower stiffness improve the isolation for the higher frequency vibration. Together, spring and damper for a passive vibration isolator system is working. Now coming to the types of vibration isolation system, one is passive isolation, second one is active isolation. Passive system does not require external power. They use components such as spring, rubber mount, air spring, elastomer pedals, and these are the simple example in inexpensive and highly reliable for the passive isolation. Coming to the other components such as engine mount, vehicle suspension system, mechanical foundation, and active isolations are more advantageous. Sensor, controls, actuators. This sensor continuously measure vibration. This control processes the information of the system, accurately generates counteracting forces to cancel unwanted vibration in the real time. Although active systems are more expensive, they provide superior vibration reduction and widely used in spacecraft, precision laboratories, and advanced aerospace systems. Therefore, passive systems are simple and economical, while active systems are intelligent and adaptive. In engineering, rarely arrive at the best design in the first attempt. Instead, they follow the design thinking process. The empathy, understand the vibration problem, identify who is the affected and perform the expected. Then they'll go for the clear and defined isolation requirement, for example, minimum allowable vibration, operating frequency, weight limitations, and environmental condition. Generate multiple design solution. Different spring materials, rubber mount can be adapted. Coming to the prototype, the development of working vibration isolator. It may be tested using CAD model simulations or physical prototype, and final test can be taken and measure the absorption of vibration and isolation of vibration can be measured. This iterative process leads to better engineering solution for the vibrating system. Vibration isolator in aerospace engineering. Engine vibration isolation. After engine generate contribute the high frequency vibration, especially in the engines, to product the avionics production, sensitive electronic items, navigation system, flight computer require the most stable mounting. To reduce the cabin vibration, improves the passenger comfort and reduce the fatigue duration, the long time flight in the structural integrity, which repeated vibration can cause fatigue cracks in the aircraft structures. Proper isolation significantly extend the structural life. Advanced aerospace system also used in intelligence vibration isolation for satellite, launch vehicle, and the spacecraft. This system protect delicately scientific instrument during launch and the operation. Now coming to the quick summarizing the important concept covered so far: natural frequency, transmitter ratio, damping ratio.